Okay, class. So today's topic is memory segmentation and address generation in 8086 microprocessor. Fine. So we have already studied a little about memory segmentation, but today we'll study in the detail about the memory segmentation and how segments are being situated in the memory and a lot of other things. Fine. So let's start with today's session. So what you're watching on the screen right now is something like we can say this is a memory of 8086, the structure that we're watching on the screen right now. So what we know about 8086 is that our 8086 microprocessor contains 20 address lines. So if I have to find out the memory capacity, that is 2 raised to power 20, it comes out to be 1M. Fine. So 1 mega is the capacity we are having here. Fine. And if it is in the form of byte segments, although it is like this, so it will be 1 MB. So what we are watching on this screen right now, this is the memory map of your 1 MB. Fine. But this is how the memory of 8086 looks like. So what these sections we have inside is these are the segments inside the memory of 8086. Fine. So what we know about the segments, that size of each segment in 8086 memory is 64K. Fine. And if I'm writing this in the form of 2 raised to power n, it comes out to be 2 raised to power 16. Fine. So what we are trying to understand from here, that this particular thing, segment stuff, will be dealing only with the 16 bits of address bus. But when we are in the overall memory, the size of the address bus will be of 20 bits. Now this thing is little confusing for you right now. That's why we have a particular topic, address generation in 8086, because there are few different stuff in 8086 related to the addresses and memory. Fine. So what we are watching right now is every segment has a capacity of 64K, and since we have the total memory which is equal to 1 MB, so how it is divided, 2 raised to power 4 and 2 raised to power 16. If each segment is of 2 raised to power 16, this is 64K. That means what? How many segments will be having? We'll be having 16 number of segments, and each segment is having how much memory? 64K of memory in each segment. So you can just look into the figure now. This is the segmented memory. Let's say segment number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. So in together all, you can see there are 16 number of segments, and this is how the memory of 8086 in the segmented form will look like. But out of them only 4 are available for us for the programmer. So what these segments are? First one is CS, code segment, then data segment, then stack segment, and then extra segment. All other segments which are shown here will be utilized for different memory operations, but they will not be directly accessible to the programmer. They will not be directly accessible to the programmer. Fine. So this is how the memory of 8086 looks like in the segmented form. Is that clear? So we have total number of segments 16, and each segment is having a capacity of 64. So that includes, that means total 1M. Fine. So when we are dealing with two different type of calculation, the calculation means when we are working inside a segment, inside any segment, this segment is having a capacity of 64K. That means what? Whenever we are working inside a segment 2 raised to power 16, the address will be different, and when we are working in this whole memory, this full memory, fine, at that moment the address will be different, because that moment address will be of 20 bits. Inside a segment it will be of 16 bits. So that creates one more differentiation, and it leads to the generation of various addresses. You might have heard them already, but today I'll discuss in detail. Fine. So first address we are having here is, first I'll tell you the definition. You note it down first, then we'll discuss about it, and there will be few numericals. So particularly be careful while I teach you about these things. So first address we are having here is called offset address. Offset address, or rather than going directly for offset address, first let's discuss about something else. Let's start with the most important, physical address. Alright, so first I'll tell you the definition. You have to note down the definition. So start noting down. So what physical address is? It's a 20-bit address. The physical address is your 20-bit address, the address of the full memory. Fine. And it's generated from the contents of two registers. From the contents of two registers. Which two registers? Which two registers? First register is called segment register. First one is called segment register. And what segment register contains? You know already. The segment register contains base address of the segments. They contains the base address of the segment. Fine. Which one is the next register? The next register is the instruction pointer. Instruction pointer. Fine. Or base register, or index register, or it can also be the pointer register. Fine. And what they contains? They contain, or any one of them will come in action. So I say which contains 16-bit offset or effective address. So any one of them on this right side will be involved with calculation or generation of the effective address or the offset address. That we'll discuss later. Fine. So basically physical address comprises of two things: segment register and any one out of them: instruction pointer IP, base register BX, index register SIDI, pointer register BP SP. It could be any one. All right, and there is a formula. There is a formula. So let's note down the formula for physical address. I write it like PA. PA stands for physical address. So formula is base address multiplied by 10H, 10H, this is in hexa, plus offset address. Fine. There is one more formula for the same, which is almost same, but there is only one difference. Base address multiplied by 10H plus effective address. Effective address. So this is the formula for physical address. You can simply use the formula and calculate what will be the physical address. The biggest part is the physical address is of 20-bit address. It is the address of the full scale memory. Fine. So what next we have here is, so now we have three new things in the physical address. This is base address, offset address, and then effective address. So let's start one by one. All right. Base address. First one is the base address, and sometimes it is also called segment base address. Segment base address. Fine. What it represents, we know already. It represents the starting location. It represents the starting location of a 64K segment. Location of a 64K segment in the memory. Fine. And what will be the source of this? We know base address. Base address will be available in a register B. Fine. But from where the base address will be coming? The source of base address will always be which? The four segment registers we have studied: CS, DS, ES, and SS. These segment registers. These segment registers will be the source of the base address. Fine. And one more thing, the value they provide by CS, DS, ES, whatever the value they provide the lowest memory location from where it is starting. From where it is starting. Fine. So base address is basically the address which is showing us from where the segment is getting started, and it will be given by the segment registers. All right. So base address is simple. Next we have is offset address. So offset address is little important. So what we know about offset address is, you better note down when PA, which is physical, found calculating a physical function, the source of offset is always IP. IP stands for instruction pointer. Fine. The source of offset is always IP. IP stands for instruction pointer. Otherwise, if the source of offset is not IP, then what will happen? Otherwise, this offset address is known as effective address. Otherwise, this offset address is known as the effective address. Fine. So there is only one difference in offset and effective. If offset address is the address is coming from the instruction pointer, that is your IP. The source is your IP. That moment it is called offset. If the source is not IP, simple, then it will be called effective address. This is the difference between offset and the effective address. All right. And what basically offset and effective will be? Basically, offset and effective address, they are the addresses inside the segment. They are the addresses inside the segment. So they will be of 16-bit, both effective address as well as the offset address. They both will be of 16-bit because they are the addresses within the segment. They work inside the segment. Fine. So that the size of the offset address or effective address will always be 16-bit. All right. Is that clear? Once you do a little practice, it will be more clear because it's just a calculation stuff. Next, we have the effective address. Effective address. So what we have in effective address, this effective address depends on which kind of memory reference is taking place. Which kind of memory reference is taking place. Fine. And what kind of memory reference it means? It can be BP, SP, SI, DI, and along with them there will be a displacement. Fine. So you know already BP stands for base pointer, SP stands for stack pointer, SIDI stands for source index and destination index respectively, and last thing is called displacement. So let's see what these things are. So first let's figure out the formula for effective address. Effective address is equal to base plus index plus displacement. This is the formula for effective address: base plus index plus displacement. So what will be the source of base? It can be from BX or BP, index SI or DI. And what could be the decimal value? It is a constant value or a variable value which will be given to find out the current pointing location. So what happens in the displacement is, displacement means after getting the starting value of the segment, find how much it is far, the actual instruction, how much it is far from the starting location. Suppose it is at this location. So displacement gives us the difference from the starting location, how much far it is. Suppose it is 8 locations away. So let's say the value of displacement is 8. It is simply the 8 value. So whatever value we are having, base value or index value, the displacement means that how far it is away from the current pointing location. So that value will be given by the displacement value. It is how much we have to move our pointer inside to connect to a particular effective address. So this is the meaning of effective address. Fine. Is that clear, all of you? Offset, effective, base, physical address. So what we know about physical address is, physical address is something out of segment, the full-fledged address of the 20-bit address. It is not related with the segment. When once you go inside a segment, then there will be a size of 16 bits. So whenever we are having a 16-bit size of address, that means it is inside the segment. When we are having 20-bit, that means it is the address corresponding to 1 MB memory map. Is that clear? So that 1 MB memory map corresponding address will be called the physical address, this one, and those who are working inside the segment, those addresses are called offset address or effective address. The difference is only one. In offset, the source is IP. In effective, source is not IP. What is the source? Base, index, and displacement. These three will be acting like a base or the source in the case of effective address. Is that clear, all of you? Are they clear? I know they may not be clear right now. So in order to have a little more understanding, I'm having some practice questions for all of you. So let's start with question number 1. Start noting. Because you will be finding some questions related to this. We need to find physical address, you will be finding offset, you will be finding segment addresses and so many things. So let me give you first question. For segment base value, are you all able to see that? The question for a segment base value 1, 2, 3, 4H. Fine. And an offset value, it is 0022H. Fine. Find physical address. Quick. Use the formula I've already given. Find the solution and tell me the answer quick. Everything is given to you. Just try to find out. You will be having these kind of questions in your examination, that you are having segment base value, offset value. You have to calculate the physical address. Look out the formula. What we are looking for? We are looking for physical address. What is the formula for physical address? The formula for physical address is base address multiplied by 10H plus offset or effective. This is the value address formula for physical address. Fine. So what do we need? We need only two things: base address and offset or effective. Are we getting the base value? Are we getting the base address? Is it given?
Yes, sir.
Just look at for the corresponding words. Segment base value, base address, they are same. So you are already having the base address. Fine. This is what? 1, 2, 3, 4, H, and it corresponds. It has to be multiplied with 10H plus next is offset. It is already given. The offset is 0022H. Come on, quick. Tell me what will be the answer here. Quick, quick. What will be the answer? Physical address. Alright, is it that tough?
Sir, 12362H.
Yes. All of you getting the answer, or is there still a problem we are having here? सबका आ रहा है नहीं आ रहा है? Or do I need to tell you how to multiply two numbers having same base? Okay, those who are finished from question number 1 can attempt the question number 2. It's already on the screen. Again, you have to find out the physical address. EA is already given, DS is already given. Tell me what will be the answer. In question number 2, only for those who finished question number 1 and those who are not finished with the question number 1, get back to the question. Let me tell you how to do it. Since we are having the same base here, so 1, 2, 3, 4 will be simply multiplied by 10 and the answer will come out to be 1, 2, 3, 4, 0. Okay, since it is again having the same base, they will simply be added 2, 2, 0, 0. Fine, and the answer will come out to be 1, 2, 3, 6, 2, H. Those who are not getting, still not getting, I don't know how to handle you if you do not know how to multiply and add two numbers. The answer for the first one is 12362H. Next one, what is the answer of the second one? The solution for the second one? Number 10 plus.
Sir, DS is for base address.
Look at the definition. That's why I always say I clear everything in the definition. What we have discussed in the definition, what will be the source of the base? Clearly written. What will be the source of this base address? The segment registers, codes CS, DS, ESSS. Fine. So whenever a segment is given,
Yes, sir.
that will always give you the base value.
Is it 4900BH plus 2359H?
Tell me the final answer.
सर इसमें बेस कॉमन मतलब कॉमन नहीं है फिर ऐड कर लेंगे इसको
तो कॉमन क्यों नहीं होगा? इट्स कॉमन. They both are having same base. Okay, so what formula we are having here? So base value will be taken at this place and that value will be multiplied with 10H plus the effective or offset. Okay, can someone tell me what value should I put over here at the base, DS or EA?
DS
DS.
Not you, other than you.
DS.
Let's see who is giving the answer. Is it Ekta? Who have just given the answer of my question? Who was she? I just want to know the name. Alright. Anyways, so at this point of time where we are looking for the base value, the value we need to put is this DS1 490B, because the source of base is always DX. Multiply it with 10, then what value we have here is effective value, either effective or offset. Fine. It will be multiplied 490B0, then it will be added to this value and the answer will come out to be what? This will be your answer. Is that clear? You said nothing to make it understand again and again. Let's come to question number 3. In this case, the physical address is given as 58230H. The physical address is already given. CS is fine. What you need to calculate is what will be the physical address if CS is changed to 7800H? What will be the new physical address if the value of CS is changed to 7800H? Tell me what will be the answer.
Sir, 5C830.
Hmm?
5C830.
Sorry, strong.
So 84230H.
Pardon?
84230H.
Sorry, it's also wrong.
Sir, 8G230.
8
G230.
G.
Yes, sir.
G कहाँ से आ गया?
Sir, 80230H.
Yeah, 80230 is fine, but I'm just surprised from where G came. The hexadecimal number system actually, the last point is, or the last alphabet we use is F. Don't go beyond that. Alright. Yes, the answer is, I'm not going to solve this. The time is already running fast. Answer we are having is, yes, 80230H. This is the final answer, and it's the right one. So now you must be getting the flavor. What kind of questions we have done in this classes? Let's have a revision. We have studied about the memory segmentation, how the segmentation looks like, the 16 segment, fine, and the four which are available to us, code, data, stack, and everything. In total, how many segments we are having? Total 16 segments. Each is having a capacity of 64K. That means whenever we are talking about a segment address will have 16 bit. It will be of 16 bit. But the moment we are talking about outside the segment, the address which is of full memory, which is physically available inside without any segment concern, fine, that address belongs to the 20 bit. Fine. So what we call this address, which is of 20 bit, that address is called this physical address. Fine. Physical address. It is a 20 bit address register and the IP base index register or pointer register, which contains 16 bit offset or effective. The formula we have here is, you can look at the formula, base address multiplied by 10H plus offset or effective address. Fine. Next we have is the definition, base address. Starting from the base, it is the value which is coming from the segment registers. We need to take care of this thing. Whatever value they provide from where the segment is getting started, and it is the location of, or the starting location of, the segment registers. It is also the lowest memory location. So that is what your base address is. Next is your offset address. So what is offset? Offset and effective, they both are same until and unless there is only one condition. If the source of offset or source of address is IP instruction pointer, then it is called offset. Otherwise, it is known as effective address. Why it is effective address? Because the source is not IP. You can see over in the formation of effective address what we are getting here. The effective address, the source is base, index as well as displacement. These three are the source of the effective address. Fine. Now we have done some numericals also, which tells us the detail about this memory segmentation and other stuff. There is one thing which is related with this. This is very important thing. What I would like to tell you, somebody should have asked in the earlier classes also, why this odd number 20 was chosen. The answer lies here only. Fine, you might have heard 8, 16, 24, 32, but this 20 number of address buses, this is quite an odd number. The designers of 86 have chosen, they have not chosen it randomly. There is a particular reason for that. Because what we need to have, we have 16 segments inside the memory, and once we have to connect to all of them, we need to select all of them one by one sometimes. So what we are going to need, we are going to generate the addresses. Fine. So in physical address, there are 5 particular bits, 5 particular locations. Each location is for 4 bit. So what 4 bits and what is the first bit? That first bit is actually the decoding location of these particular segments. So by this 2 raised to power 16, 2 raised to power 4, by this what I'm able to get is I'm able to select all the 16 segments. By 2 raised to power 4, how much decoding states we'll be having? We'll be having 16 decoding states, and I could be able to select every segment inside the memory. So that's why it is of 20 bit. Fine. I hope I made everything clear about memory segmentation.